Okay, today we're talking about section 4 of chapter 2, parallel and perpendicular lines. Alright, so this reads, given any two distinct lines in the Cartesian plane, the two lines will either intersect or not. In this section, we investigate the nature of the two lines that do not intersect, parallel lines, and then discuss the special cases of two lines that intersect at a right angle. Okay, so it reads the special case, okay, because imagine we have us a Cartesian plane here. Right? So we have three choices for lines, okay? Lines that do not intersect, we know as parallel. Okay? Lines that intersect at a right angle here, we call that perpendicular. Right? But most lines, they will, intersect, right? Or we can just we'll go this way. No, it looks kind of let's see. All right, so I was gonna say this, but that kind of looks like 90 degrees, but obviously it's not. It doesn't. It is not 45. So let's recap. We have parallel lines. We have perpendicular lines. That's the special case, right? But realistically, most lines are that they intersect, but they're not parallel or perpendicular. Okay, so that's why we see it said as a special case. Okay. These two cases are interesting because we need only know because we need only know the slope of the two lines to determine whether the lines are parallel, perpendicular, or neither. Okay, so it's really easy because all we have to do is look at the equation. We might have to rearrange the equation or something, and once we figure out the slope of the equation of that line, we can tell immediately if it's parallel, perpendicular, or neither. So I wonder if this will fit on our current page. Does. Tight squeeze, but it does. Okay, so as stated, two lines are parallel if they do not intersect, or in other words, the lines do not share any common points. Okay, so let's see. Without having to read all that, let me see if I can skim through here. Okay, well, in all honesty, we can cut straight to this. In other words, parallel lines have the same slope. Okay, so here we see two lines. They are indeed parallel if you extended them, right? They're parallel lines, and their rise and run have the same ratio. Okay, so the ratios of the vertical rise to the horizontal run of any two parallel lines must be equal. So this leads us to our theorem here. Two distinct non-vertical lines in the Cartesian plane are parallel if and only if they have the same slope. Okay, so this if and only if statement, is a mathematical statement, mainly used in mathematics, right? I mean, you can hear it in other things, maybe like in philosophy or something, right? If and only if, or logic. I forgot the if. There we go. If and only if. What that basically means is that we could read this statement forward and backwards. So let's underline that and underline this. So basically, reading it forward is just the way it is, right? But reading it backwards would be, they have the same slope if and only if two distinct non-vertical lines in the Cartesian plane are parallel. So whenever you see the term or the phrase if and only if, that just means that that it's logical forward as it is backwards. Okay. Okay, so there's proof of it. I'll go over this. Oh, what do I mean? Do current page. Let's do that again. Let's do the next page. Okay, so the proof for this. Okay, so again, in mathematics, when you make a statement, you can't just back it up with, see, it's correct for this and it's correct for that, right? You have to make an airtight proof for every single case. All right. Let's see here. Trying to think of a way I can kind of phrase that better. Let's see. So, if I went to the Kroger here in town, okay, and I go to the meat section, and nobody is buying any meat. Okay, could I logically conclude that nobody eats meat? No, right? I can't rely on anecdotal evidence to say, hey, you know, nobody here in Hendersonville eats meat, right? And that's kind of what mathematical proofs are, right? You can't just have a blanket statement based on, you know, the 1, 2, 3, 4, 5, you know, cases you have. You have to have a statement that is airtight and it fits for everything. And I'm probably getting a little too deep into this, but I do get a little excited when I talk about proofs, mainly because I did them until my eyes bled for most of schooling. But anyways, not to get too technical here. I don't think this is abundantly technical, but if you kind of have to rely on the law of similar triangles. Okay, so the law of similar triangles. I forget the exact wording, but basically two triangles that, you know, that they could be different they can be different sizes, right? But their ratios will be the same. Okay, the ratio of side A to side B is the same as the ratio of side alpha to side beta. Same with, and these angles are all the same. Okay, so that's what's being used to prove the theorem of parallel lines. Okay, so without reading it, if you are very interested, take the time to really understand and get an understanding of what this is saying. But again, realistically, it's just saying, of course, we have triangle ABC, and if you recall, if you read that triangle ABC, B, the middle one is where the right angle is located, right? So this triangle here, ABC, B being here, right, is equal to the triangle of DEF, based upon their sides, based upon the law of similar triangles. Right? But I know you guys don't care about proofs. At least, it's been my experience that, well, as a matter of fact, this is my, holy cow, this is my 5th year teaching. Okay, so this is my 5th year teaching, and 5 years into my profession. Now, at the same time, I don't know what you guys are going into because we didn't have our good syllabus day. I talk on syllabus day, hey, what are you going to go to school for, all that good stuff. So COVID kind of ruined that. But leading up to this year, I've only had one student that's ever been like, you know what, I'm going to go into math. They're going to be a math teacher. And obviously 0 wanting to go into the mathematician profession, which honestly boils down to teaching it out of college. Obviously mathematicians are used in other fields, but it's usually mixed with other things like programming and something like that. Anyways, I'm rattling on. Let's move on. So this reads, show that the lines y is equal to negative 2/3 x minus 1 and 4x plus 6y are parallel. Okay, so we can do this many different ways, and we're going to do it the way that I told you I like to do things in the last lecture. Okay, so I'm going to, that's not what I wanted. I'm going to denote that in, let's not use red. I'm going to denote this one in blue and this one in yellow. Okay, so what I'm going to do is basically I'm just going to write the equation, and this one doesn't require too much thought process because it is already in that slope-intercept form I'm looking for. Okay, so looking at this particular problem, what is my slope? Well, if you recall, slope is y equals mx plus b, right? So the m is this, negative 2/3. So my slope is negative 2/3. Done. Nothing much there. Okay, now this next problem is a little bit more, just a tad bit of equations. I'm not quite equations, a tad bit of steps here. Now, if you recall, at the end of the last section, you could do, what was it, like C over A or C over B. I honestly, and I told you this at the end of the last section, I forgot because I just don't use it, right? To find the slope. I just usually take the equation and then I change it into slope-intercept form. And so let's do that. Okay, so if I want to put this into slope-intercept form, I need to I need to just isolate the y. I need it to look like this, right? Y equals mx plus b. So first thing I'm going to do is I'm going to subtract 4x from both sides. So I've got 6y is equal to a negative 4x plus 12. I'm going to divide both sides by 6. So I've got y is equal to negative 4/6x, and then plus 2. And then of course this, well, no, I mean not necessarily the x as well, but this can be reduced to what? Negative 2/3, right? So I've got y is equal to, and let's just go ahead and write it there. I'm going to erase this, and because we hopefully we can agree that negative 4/6 is the same thing as saying negative 2/3. Okay, negative 2/3, and then I can say, well, the slope of this line, the slope would be this, which is negative 2/3. Okay, and then we see that we have the same slope for both of them, and therefore we have shown that these two lines are indeed parallel. Let's see, and of course this particular problem in the text, it does do the whole standard form thing. I guess it was what, negative a over b and then c over b, but I mean we essentially did that when we are putting it into slope-intercept form. All right, so we're still doing that division, okay? In my opinion, in my humble opinion, we're not doing anything extra, but it's just going straight into slope-intercept form. Let's see if this will fit anywhere. It'll fit right there. All right, and that's just a drawing of the two lines being parallel to one another. All right, next up, so we talked about parallel lines, so now let's talk about perpendicular lines. Okay, so if two distinct lines are not parallel, okay, so I told you at the beginning we have three options: parallel, perpendicular, or neither. Okay, well, if they're not parallel, then they must intersect at a single point. Okay, so two lines are going to intersect at a single point. You know, don't really know where without knowing the equations of the lines, but we know that they're going to intersect. And if the two lines intersect at a right angle, then the lines are said to be perpendicular. The slopes of the perpendicular lines have a special relationship that is stated in the following theorem. Now this theorem might be a little more confusing, okay? But let's go ahead and read it. Two non-vertical lines in the Cartesian plane are perpendicular if and only if the product of their slopes is -1, okay? Now, there's nothing wrong with that. It is true, but I know you guys are probably used to the term negative reciprocal, right? At least that's how I was always taught in high school. That's how I was taught in college. And I'm gonna be honest with you, I'm pretty sure my textbook in college said, negative reciprocal. But at the same time, maybe I didn't really care about the theorem like I do now. But negative reciprocals. So we know. Well, first of all, let's talk about what a reciprocal is. A reciprocal, okay. Now, if we have a over b as some fraction, okay, then we know the reciprocal of that would be b over a, okay, and that would be the reciprocal. When you say a word over and over, it just gets kind of weird, right? Well, and it would be the negative reciprocal. So you just put a negative sign in front of it, and that is it. The negative reciprocal. You flip the fraction, and then you change the sign. So if this is a negative, then this turns to a positive, which it's an implied positive. One more thing regarding that. Okay, so if I just have a slope of a. Okay, well, the reciprocal of that would be 1 over a, right? Because a is simply 1 over, or a over 1, so the reciprocal would be 1 over that constant. Let's see. I think that about does it. Actually, let's actually rotate back to the theorem here, okay? So I said that if we had yeah, okay, so I said if we had a over b, then the reciprocal, I'm going to put multiplication here because I'm going to try and follow along with this theorem, all right? The reciprocal would be a negative b over a, okay? Well, if we did this multiplication here, right, a times b times, I'm sorry, a over b times negative b over a, well, these, cancel, right? And then we have a -1. And that's exactly what this theorem is stating. So that's where we get that information. I think that about sums it up. Of course, you have your drawing there, or your graph. Sorry. Okay. All right. So same procedure as the first problem that we did. All right. We're going to just take. Let's just blue. Let's just underline that in blue and underline this in yellow and just show what I'm doing here, okay? So first, I'm just going to go ahead and subtract 3x from both sides. So I'm going to have a -6y is equal to 3x minus 12. I'm going to divide both sides by negative 6. I'm going to have y is equal to, okay, so negative 3 divided by negative 6, well, that is a positive 1/2 x, and then I've got a plus 2. Okay, so that's, oh yeah, and then the slope here is 1/2, okay? So right away, I'm going to say that what I'm looking for over here, when I'm done, is I'm going to be looking for the negative reciprocal. So 1/2, this 1/2 is a positive, so I'm looking for a negative of it, right? The opposite sign. And then 1/2, well, the reciprocal of 1/2 is 2/1, or just -2. So I'm looking for -2 slope on the next equation. Excuse me. So let's begin. I'm gonna go ahead and subtract 2x from both sides, and we can already see it, right? So we've got y is equal to -2x plus 4, and like I said, there's not much else arithmetic we need to do, right? The slope is -2, and that's exactly what we're looking for. So these two slopes, they are indeed negative reciprocals of one another, and they are indeed perpendicular. And if we were to graph this, that's what we would have. Okay, let's see what else. Yeah, the book does it the way that we learned at the end of last section, but again, put it into slope-intercept form, and you'll be a-okay. And again, you're still doing it the slope-intercept form. Let's see. We will snip this. Not much could be said here because I mean we've talked about it, right? This is just a summary, right? That we'll just put in the notes. Okay, that was bad. Let's try that again. Dang, that's even worse. Maybe I should start down here. That's what I'll do. There we go. Okay, so I'm left-handed, so I like to drag from right to left. Not that you care, but I'm just saying. All right, so let's see here. We're gonna do this. We're gonna do A in blue, B in yellow, and C in white. Well, I underlined it, but you can't see it. But there it is, C in white. Okay. Actually, I can just do this. A. All right. So we need to determine whether two lines are parallel, perpendicular, or neither. So here we go. 3x minus y. So I'm going to go ahead and say negative y minus 3x. I'm sorry. Negative y is equal to, sorry about that, negative 3x plus 4. I divide both sides by negative y. I've got y is equal to a positive 3x and then a minus 4. Okay, so this slope is a 3, and so let's do the next equation. So I'm going to go ahead and rewrite it with, looking here, by subtracting x from both sides. So I've got a 3y is equal to negative x plus 7. I divide both sides by a 3, so I've got y is equal to negative 1/3 x plus 7. So I'm going to look here. Okay, so I'm going to ask myself, are these the same? No, obviously. Are they the negative reciprocal? Yeah, they are actually, right? One is the negative reciprocal of the other, and the other is the negative reciprocal of the other, right? So A would be perpendicular. So let's do, just write perpendicular. Okay, and B. All right, heck yeah, B. B's already done a lot of my work for me, hasn't it? So I've got 1/2 x plus 3. So the slope here is just simply a 1/2 x. Perfect. The next equation, I'm going to go ahead and subtract x from both sides. So I'm going to have 2y is equal to a, is that right? 1/2. I guess. Okay, here we go. 2y minus x plus 1. Oh, I see what they're doing. And then we divide both sides by 2, so we've got y is equal to a negative 1/2 x plus 1. So we're going to look here. Okay, so are these the same? No, one is positive, one is negative. Okay, are they the negative reciprocal? No, right? The reciprocal of 1/2 would be 2 over 1. This is not 2 over 1. So they're not the same, and they are not the negative reciprocal, so they are neither. And I'm going to just put an N here for neither. Maybe I should N-E-I-T. We'll put neat. Okay. All right. So next up will be C. And honestly, not that that matters, but since this is perpendicular, this is neither. I'm just going to assume that C would be parallel, right? Okay, so looking at this, x is equal to -1. Oh no, we can't put this into slope-intercept form anymore, can we? Okay, because we don't have that y, right? But if you recall, if we have x is equal to some number, right? Hang on a second, let me go back and check something out. Okay. I don't really like that theorem at the beginning, but we're just going to roll with it. Anyway, so if you recall, and let's go ahead and just to kind of redo our brains here. If we have x is equal to -1, you recall that then that would just be a vertical line through -1. And if x is equal to +3, we have that vertical line through +3. Okay? And that's it. And obviously these two are parallel, right? Because these two lines are vertical lines going straight up and down. And one moment, let me go back and read this again. I'm looking at this theorem here. And it says, two distinct non-vertical lines so I guess that's also meaning it does work out for vertical lines. Okay, but anyways, so here we go. These two are vertical lines, so C would indeed just be parallel. So we'll put par. Okay. All right, now we get to the fun part. Oh my goodness, we need to put this in point slope form, slope intercept form, and in standard form. All right, so hopefully, if you didn't get enough of that over the weekend, then we could do it again. So here we go. Let's do the thought process here. So we need to find an equation of a line parallel to the line 2x plus 4y. Okay, so right away, let's go ahead and do this. Let's go ahead and break down that equation into slope-intercept form so I can figure out what exactly the slope is. Okay, so we're going to say 2, actually we're just going to go ahead and subtract 2x from all sides. Is that fine? So we're going to have 4y is equal to -2x plus 1. I'm going to divide both sides by a +4, so I'm going to have y is equal to, and then it turns into a -1/2, right? -1/2 x plus 1. Okay. All right, so that takes care of that. So this means my slope here, my slope of this the equation, this line is -1/2. Perfect. Okay, so that's the slope of that line. And we're trying to find an equation of a line that's parallel to that line. Okay, and it's passing through the point 3, -5. Okay, so check this out. First of all, if you recall, I said that the point slope form is my equation generator. Everything that I do regarding equations of lines stems from that. In order to get to standard form, I need slope-intercept form. In order to get to slope-intercept form, I need point-slope form. Okay, so point-slope form is essentially the equation generator, as I mentioned before. Okay, I also said that things are aptly named in the world of mathematics. So this point-slope form means that I use it when I have a point and when I have a slope. Okay, which I just so happen to have a slope, and I'm given a point. Okay, so what I'm going to do is I'm going to write that in my point-slope form. So my point-slope form y minus y1 is equal to mx minus x1. So I'll have y minus, and then y1 here is a -5, so it's going to be y. And then I know I say you probably shouldn't do this, but because I'm putting this in 3 different forms, I'm going to go ahead and say minus 5 is a plus 5. Okay, I do encourage you to do this and then proceed, but because of space, I'm going to write plus 5. Okay. Hopefully, since I made such a big deal out of it, I will now have remembered. But I usually do the minus 5 just so I don't cut any corners and just so I can be absolutely sure that my arithmetic is correct. Anyways, so I've got y plus 5, and then it's equal to, okay, so I need a line that's parallel, so I just need the exact same slope, right? So, and I'll put that in white here just to show where I'm getting stuff. -1/2, and then x, and then -3. Okay, so this is point slope form, so I'm going to go ahead and denote this as point slope. All right, and now I'm going to solve this for y to get into slope intercept form. So I'm just going to do a couple things just in my head, if that's okay with you guys. I'm going to go ahead and distribute here and then subtract 5 on my next line. Okay, so it's going to be y is equal to, and I'm distributing that -1/2, so it's going to be -1/2 x minus, oh, that's going to be plus, actually, plus 3/2, okay, because I'm distributing here, plus, let's see, 3/2, and then I subtracted 5 from both sides, okay? Well, if I subtract 5 from both sides, and now I'm looking at this, 3/2 minus 5, they're both constant, so I need to be able to subtract 5 from 3/2. So I need to get a common denominator, and that common denominator would be 2. So I can rewrite 5 with a denominator of 2 as 10/2, right? Okay, so I'm going to go ahead and let's get rid of that box, actually. So we can say this is 10/2. 10/2. All right, well, what's 3/2 minus 10/2? Well, that would be a -7/2. So -7/2. Oh, the whole thing is -7/2, sorry. -7/2. Okay, let's fix that up just a little bit. It looks the exact same. Okay, whatever. All right, and this is slope intercept, okay? Slope intercept form. And lastly, we're going to put this into standard form. If you recall, standard form, what I do, and let's actually, yeah, we're going to go ahead and change the color here. -1/2 x minus 7/2. Okay, so I'm going to go ahead and change this to a different color so it's not running together. Let's say -1/2 y is equal to -1/2 x, and then minus 7/2. Okay, so that'll be slope intercept form. And then lastly, if you recall, to get into standard form, I need x's and y's on one side. Okay, so this would be 1/2 x plus y is equal to a -7/2. And then if you also recall, I need to have this value here to be a, well, not going to say the whole thing, but I need my coefficient from my x to be a +1. So how do I get that to be a +1? Well, I multiply this entire problem by 2, and then distribute that 2 through in order to get everything to be a +1. Okay, so that would be, we'll put it over here. Okay, so if I multiply everything by 2, I would have x plus 2y is equal to -7, and this will be standard form. Standard form. Maybe I can put SF. How about that? SF might be better. SF, standard form. Okay, so hopefully I didn't confuse you too much here. But to recap, what I did here was I took the original equation here, right, and then I solved for m to get my slope. Okay, once I got my slope, I was able to plug that slope into my slope or my point slope form because I have a point and a slope, and then boom, there's my point slope form. From my point slope form, by solving for y, I can get to slope intercept form. And then from my slope intercept form, by putting my x and y on one side and clearing any fractions, I get to this. Okay, so again, something we've done before. Nothing groundbreaking there. Okay. New page. Okay, one moment. Alrighty, so here we go. So we need to find the equation of a line perpendicular to the line y is equal to negative 5x plus 2 that passes through the point. Write the answer in slope-intercept form. Okay, so this is a lot easier, right? We don't have to put it in all three forms. Not only that, but we are already given the equation in slope-intercept form, so I can already tell you what my slope is. Okay, so my slope is what? Negative 5, right? Negative 5 right here in front of the x, right? And I've got my point is a 3, negative 1. So let's pop in my equation generator here, right? So I've got y and then minus a negative 1, so I will go ahead and write that out this time. And then it's equal to m, which is negative 5. Ooh, I almost messed up there. How did I almost mess up? Well, this is saying find the equation of a line perpendicular. Okay, so what is the slope perpendicular to negative 5? Okay, well, if I were to take the negative reciprocal of that, well, the negative reciprocal, right, basically means we're just changing that sign. So it turns from a negative to a positive, and then it's a 5 over 1, right? So the slope that is the negative reciprocal, or the perpendicular slope, would be a positive 1/5. Okay, so I will put that in white still, right? But just know that it is not the same because I'm looking for a perpendicular line. Jeez, okay, let's try this again. Hey, that's not bad. Okay, and then it is what, x minus 3. All right, so let's fix this up a little bit. So now we have y plus 1 is equal to, I'm gonna go ahead and distribute that 1/5, right? So I'm gonna have a 1/5 x, and then it's gonna be minus 3/5. This is just a jumbled mess. My 5s are horrible right now. 5x minus 3/5. I don't know if that's much better, but we're just gonna roll with it, right? All right, so now I'm gonna subtract 1 from both sides. So I've got y is equal to 1/5 x minus 3/5, and then I subtracted 1, okay? Well, again, focusing in right here, okay, in order to combine these, these fractions, right, these constants, I need to have a common denominator right here, okay? So how do I rewrite the number 1 with a denominator of 5? Okay, well, that's easy, right? It's just going to be 5 over 5. Okay, and I'll go ahead and put it on this line down here. 5x minus 8/5. Okay, so this is the equation of a line that is perpendicular to this equation, and it passes through the point 3, negative 1. And real quick, I was thinking about this. So I don't know if, well, as a matter of fact, I know you can't see it, especially on the YouTube video. During the Zoom link, you can, but in the YouTube lecture, I have a toolbar right here. Okay. So just in case you're ever just like, hey, you have a lot of room down there to work. What's up with that? Well, what's right here? It's because I have a toolbar there, and I can't necessarily write on that toolbar. So if you're ever just like, why does he leave that space empty? That is why. Okay, and I think that about does it. So we can do this, and let's go ahead and snip the pretty graph because mine are awful. Current page. Boom. Okay. All right, and that concludes this lecture on perpendicular and parallel lines.